Cool. Welcome to the Go Guild November. Announcements and news as usual. 125.4 was released. My apologies, my notes there. That includes fixes to the compiler, runtime, and crypto. Some really good news. Go turns 16, marking its anniversary with major releases 124 and 25. So just kind of a look back of the last maybe year and a half, 2 years. They've had new testing tools, container aware scheduling, the flight recorder, runtime improvements, and yeah, a lot of juicy stuff. Official MCP SDK, and they're expanding support for AI. So a big milestone, and amazing that Go is such a firm favorite in the community. Only after 16 years, because it's a bit of a newcomer, right? So that's really great news. JetBrains did some really cool Go surveys to celebrate Go's birthday as well. So yeah, they kind of asked Go devs what's their most popular bits and surveys and things like that. So they did framework, so you can see kind of Gin is really popular. Interesting to see Gin over NetHCTP, but I think Gin's been around for donkey's years. Followed by closely Echo and Fiber, and then you've got testing on the right. Now, I don't think there's any surprises here. Built-in testing is obviously at the top there, but you've also got Testify coming in as well. But quite interesting. They also asked about IDEs and what devs' favorite IDEs are. So 47% of Golang, 29% Visual Studio, and then some I use Vim, by the way, kind of people. And then we've also got some Atom and bits and pieces like that. No surprises with Golang is number one. Golang is very powerful. And then we've got AI assistants with Copilot and Cursor taking the top spots. But interesting. There's an article there if you want to go and read it. What's happened in the community? Did anyone notice yesterday that their internet went out? I was just watching a video actually on this. I think it's a Primogen. And basically there was loads of 500s caused by a DB change. It was the bot detection management feature. So forgive me, I've just learned this, but they basically have like 20 features to decide whether or not you are a bot when you go onto a website. And a DB change meant that all of a sudden, instead of 20, there was now 200 from what I vaguely know. So it got this file that was managing these features, as they call them, got really big. So CDN workers, all that stuff just kind of went to kaput. So they rolled back this feature file. And I think a lot of the internet is kind of like, oh yeah, it was in Rust, and Rust, that should be not happening in Rust, and blah, blah, blah. So yeah, I think it was caused by that unwrap little unwrap thingy majority there. My Rust is terrible, but I guess things can fall over even if it is very, very secure languages. But interesting, and glad it's back now. Feel sorry for the guys that rolled that one out. There's a really interesting article on Reddit about the best Go blog posts of all time. This is just really good read if you've got 20 minutes. Lots of really juicy articles. I think Matt Ryer's one is just about how I create HTTP services after 12 years is just below this, the one here. So yeah, really good. Full code can now debug low-level cryptography, and I don't know how I feel about that. I feel a bit nervous. I mean, this article kind of went into like failing tests and bits and pieces. But yeah, experience the potential of AI tools like one-shot debugging and kind of thing. Is there something scary on the horizon? Who knows? A reminder that A Cup of Go is out on as a podcast if you fancy listening or learning some Go on your morning runs. And this is, again, another good article, 15 subtleties that you may not already know about Go. Some good refreshers there, some new language features as well. Some tools. So onto a section where I'm kind of digging around the internet to see what's available in Go, or what's new and what's well tested. This really perked my ears. So this is a Vite plugin, sorry, Vite plugin, I should say, bringing Go to the front end, which is cool. So basically, you write Go code in JS files, and it compiles to WebAssembly, and everything about it is the same, but you kind of just use this use Golang thing, and then you just write your Go code, and it will compile to WASM this plugin. So really powerful if you want to do some bits on the fly in Go in JS if you're building a website. So an example here is kind of hashing images. It has these library functions where you can copy bytes to Go and set globals and things like that. But yeah, that's really interesting. DocX Go, really nice API for manipulating and building Microsoft Word documents. Has a wide variety of doc features, alignment, paragraphs, etc., etc. And I think this just API is just really nice to look at. You can create a new document builder. You can add a paragraph and then go ahead and build it. It's just a nice builder pattern. Maybe it supports kind of you can use that for building nice PDFs for like invoices and stuff. I'm not sure, but a very nice API. Similarly, Excelsize, I don't know how to pronounce that. While we're on the subject of Microsoft Office, sorry. I looked at this documentation. I found that the docs was nothing like I've ever seen before. It was incredible. And I think it was the same guys that've done the doc stuff. And yeah, it's just really cool that you can create 3D charts in Excel and Go. Anyway, my nerdy brain thought that was quite cool. So similarly here, you can do like a new file, a new sheet, and you can set values and save and things like that. So quite cool. Go Meridian provides type-safe time zone handling. Apparently, Meridian solves a fundamental problem in Go in that time zone information is data and it's not a type. So time zone information sometimes can get lost, and this package aims to fix it. So on the right here, you can kind of call a utc.now. And then you've got formats and things like that. So yeah, quite interesting. I guess when you've got some really things that are heavily dependent on time, transactions, finance, I'm not sure, but quite a cool package. Crush. So Crush Charm Bracelet, excuse me. Charm Bracelet, who brings you bubble tea, have had an AI baby and have made Crush, and it's kind of allows you to choose between different models and sessions and things like that. I really like the look at. I actually haven't tried it. I do want to try it, but I think even if you're just building a bubble tea CLI, I think looking this at inspo is going to be really useful. I do want to do a bubble tea UI at some point, but yeah, it looks really cool. Onto our knowledge share, and Eleanor, thank you so much for joining us. How are you?
Not too bad, thanks.
You've been jet setting this year, right? You've been a few places in some Go conferences, right?
A little bit. No, the furthest I've been is Italy. So I mean, it's not like I've been halfway around the world or anything. But yeah, I had quite a busy summer period. So
nice. Italy sounds really cool to get, even just to have a little cheeky break in Florence. No,
I'm obliged to pimp Go Lab. If you ever get a chance, go to Go Lab.
Oh, really? Okay.
It's usually held in Florence, but they're moving to Bologna because Italy's having awful problems with inflation, and Florence has become very expensive for Italian devs. But they do that alongside a Rust conference, Rust Lab. They held them both in the same building one year. It was very disconcerting. You could tell the difference between Rust and Go developers just by looking. I was not expecting.
Well, you've heard it here first. For power folks, if you've got budget to go to a conference, choose Italy rather. Go Lab.
Yeah, this coming year it's in Bologna. So I don't
Bologna.
know what Bologna's like, but I've heard good reports, and it's the only conference that I attend where they care about the food for non-ethical reasons. There's
Fair
enough
enough.
that they're going vegan, but they want to make sure you have happy food.
Yeah, absolutely. I can imagine that. Well, you're going to be doing a talk on the Paranoid Network program. It's really nice to have you. I've always been really intrigued by your talks. I've always noticed you at the GopherCon, and yeah, it's really nice to have you on the Go Guild. I'll stop presenting.
I cannot guarantee this will work. Well, I wrote this talk to give remotely to a conference in South Africa, to an audience of 9 people. So this is pretty much the same setup, to be honest. But it's always quite difficult getting the energy level right when you're actually, sat down as opposed to walking. So we'll see how this goes.
No, you're fine.
Right, I am about to share a window. No, not this one. God help us. This is where you've discovered I'm completely incompetent in using a computer, because I am. Right, can people see that?
We can indeed, yeah.
Right, so if I now go play, can you still see it? Oh, continue to share. There we are.
Yes, it's perfect, yeah.
Yep.
Right, brilliant. So somebody shout at me if we've got less than 10 minutes left, and I will speed through the remainder, because I have no idea how this is going to go. So I have a lot of history with doing weird things with networks that dates back several decades, but this is some of my more recent stuff. And I have a co-conspirator that I work with who's a cryptographer. I am not. And yes, probably enough said about that. All right, Go is one of the few languages I work with that's actually really well designed for writing network code. And I think part of the reason for that is that whilst it grew out of an internal project at Google to have a better alternative to writing things in C++, something where to have more manageable code bases. From the very start, it was supposed to be replacing network services that have been written in C++. So Go does a surprisingly good job of doing networking. So we're going to start with the basics. We're going to run through these fast. Then I'm going to hopefully get onto some cryptography and run through that fast. Don't believe a single word I say. Double check everything with legitimate resources. And here goes. So first up, our good old friend HTTP. No, I haven't color coded these, so that's fine. Can I convince it to give me a pointer? No. All right. The first thing to note is that by default, out of the box, you can just launch a HTTP server and you can put a whole pile of functions on it that have roots, and it will just respond to the roots quite nicely. You can do much more complicated things by having your own version of a web server, but out of the box, you get the ability to do HTTP. And not only do you get the ability to do HTTP, you get the ability to do HTTPS as well. TLS is just there. The only real distinction is that for TLS, you have to provide a server certificate and a server key. The cert will be used so that the server can prove to clients connecting to it that it is who it claims to be. And then the server key is what will actually be used to give the client connecting a public key to encrypt things with, to set up a TLS connection to talk to that server. Most of the communication does not happen using public key encryption. That's literally just to do the key exchanges and the setup. After that, it's all done with symmetric crypto, which is an awful lot faster, and I'll talk about that later. You've got a few other little conveniences in here. You'll notice that you can set content type on a header and things like that. The most noticeable thing is if you're in main, line 4, you'll notice that write takes slices of bytes. Now, the great thing about Go's I/O libraries is they all basically work by either taking a slice of bytes or giving you a slice of bytes. This means you can write code that does networking, and you can write code that does file handling. And for the most part, you can actually have the same functions doing the actual work. You're just doing some setup. So in this case, I need a HTTP response writer to be able to write to a HTTP response. But the whole way in which I interact with it is just the same way as I would be with interacting with a file. And that's really nice. I mean, it's there aren't many programming languages that take that particular approach. And as far as the network's concerned, it's only interested in bytes. There are some funky things to do with bytes, but I'm not going to go into that. This is an example of what a server key and a server certificate look like. I think this is probably a 2048-bit key. Looking at it, it's quite big. It would be half that size if it was 1024. Long ago, when the internet first developed some sense of secure communications for browsers, it was 128 bytes. Never ever use anything like that. It's not secure. Okay, so I'm now going to show you a few things that you can actually do with the built-in with the standard library, but quite frankly, that doesn't teach you anything. So here, what we're actually going to do is we're going to serve a file over TLS. So if you notice, we've still got our listen and serve TLS function down there that's setting up our server. Because that'll actually return an error. I've decided to just send its error directly to the log. When setting up debugging in any of this stuff, log.println, .printf, .sprintf, or whatever, all an awful lot better than peppering your code with funct.printlines, etc. It's a very bad habit because I've been programming for 44 years, and breaking bad habits from 20 years ago is really hard. But this is something I'm trying to actively break myself of as time goes on. I'm trying to move over to just using logging for debug messages. On the right, we have the most boring web page that you can possibly imagine. It literally is a static page. It will just give you a div that says hello world. We've got a few bits going on over on the left. I've got a helper function I've written for finding out a directory based on a parameter on the command line, and that's probably explained down here. I've got some other little helpers just for doing string stuff, because Go isn't as nice for string stuff as I would like. I say that coming from Ruby, where basically you can do anything with strings in like a one-liner. In Go, I often end up having to write these little helper routines. It will just take care of some of the stuff for me. So in this case, I want to remove duplicates off the command line. In this particular case here for get dir, I want to remove duplicated slashes because that's meaningless. I've got a bit of code for adding a suffix. That's because you want to be able to put a suffix on a file name and things like that. And there's some other bits going on in there. It's not really very interesting. But the point is, it allows me to then use read file from IOUtil to just basically slurp a file directly in and pump it straight out over a network connection in response to somebody asking for that file. Now, there is a method in the HTTP package for doing this automatically, and I can never remember what it's called. The point of writing your own is that then you can put your own filters in and you can decide which files can and can't actually be served, which also means that you might make mistakes in that, but that's part of being a programmer. The other nice thing here is you'll notice on handle func, if the file is not found, I can just automatically send a HTTP not found back. And that's kind of nice because it means that a client of, well, it's kind of nice for a well-behaved client that just wants to go, oh, I didn't find that file. Obviously, if I was an attacker, I could use that to recurse through and find out what files exist. But for my example, that doesn't matter. One of the things that you want to do, though, in any code that you write, is you want to minimize the amount of I/O that you do actually take on and the amount of processing you do. So I'm going to introduce this cache so that when files are loaded, they're cached. And then if they're found in the cache, we can serve it from the cache. If they're not found in the cache, then obviously we can load the file. Now, if you're writing a real world version of these, you'd either at that time check the stat on the file to make sure that it's, see what the timestamp is, make sure the timestamp isn't newer. Or you might well just have it so that you had a TTL, so time to live. So that's how DNS does it. DNS takes the view that if something's been cached for X number of seconds, then it might as well refresh its cache after that amount of time. And something long-lived, you give a long time. Something short-lived, you give 60 seconds. So in this case, and a cache is literally just a map. There's nothing exciting about it. See, I've also written a little helper here for this program that will tidy up the page not found return, so I can actually send back something a little bit more useful. If there is a missing a file called missing, then I will quite happily serve that back instead. So that's like having a 404 override page. Don't think there's anything I want to really talk about in main, because it's just really doing the same stuff again. Yeah, we've looked at those. Yeah, I mean, one of the things you'll notice about my coding style is I tend to abstract anything off I can. I very much believe in dry. And that's coming out of the Ruby world. It's kind of a religion over there, possibly too much so. But it does make it much easier when you come to change a code base, because now you've only got the one place you've got to change things in. And then you've got the balance between overly specialized functions and too many of them, and overly generic functions and having to remember parameters and having to have APIs that don't change much. But that's one of those trade-offs you sort of, you suck it and you see where it ends up over time. Now, I don't normally play with HTTP at all, to be honest, in this kind of way. I'm using HTTP normally to tunnel things. But I thought if I was going to cover it, I might as well cover also using a little bit of JSON over TLS. So this example, basically, we just have exactly the same kind of web handler we've had previously, but we're going to serve up a little bit of JSON. Now, if we've got static JSON, we literally, all we have to do is just set content type as application/JSON. I think there's also a text/JSON, if I remember rightly. But I don't think anybody ever uses that. It seems a bit of a weird one. But so this is just a very simple example. That's all it's doing is that. It's giving you the remote address of the connection though on your logs, so you can see who's actually asking for the file. So that's a nice little thing to always take account of if somebody is asking for something. But now we can come into something a little bit more. We're starting to move into something a little bit more interesting. If we are going to be pumping JSON over TLS, we probably actually want to be doing slightly more complicated stuff. So how to describe this? All right. I can't see any hands, so nobody has to raise them. But how many people write their code in a functional style? Because from this point onwards, we're going to be using quite a lot of functional style in our code. I do this because higher order functions, which are functions that take functions, make it much easier to wrap up an awful lot of kinds of infrastructure code. So in this case, I've got this function parallelize. And what parallelize is going to do is it's going to do as many TLS client connections at the same time as I want it to. And it's going to then, for each of them, fetch a web page. And then it's going to read from that web page the content. And it's going to split it up as records and it's going to print them out. So this is a client for that. Boring static serving, much more interesting client application. So we have to set up a TLS client, and that's basically the same as just setting up a normal client, only we have to give it a cert. We need to give it a random number source. So in this case, rand.reader comes from crypto/rand. This insecure skip verify. Now I'm saying true here, and that means it's not actually going to check the validity of the certificate, because I'm doing the testing with a self-assigned certificate. But in real life code, you'd set that to false, and that actually makes sure that the certificate that you get is valid for the domain that you are on. You can have a similar thing at the server side to test a client certificate, but as far as I can tell, nobody uses client certificates anymore. Web browsers used to support them, but it just seems to have deprecated at some point. As far as fetching the web page is concerned, that's fairly boring code. We've seen that before structurally. But what we're basically doing here is we do a get on a URL. We make sure that we will close the body if the URL get succeeds. If it fails, it doesn't matter. There's no body to close. And then if the status code that we get back is a 200 or something in the 200 range anyway, then we can read that body and we can call a function. You'll notice that to actually call fetch web page, we take a client connection that we want to do our get request over. We give it a URL that will be used with that client, which is interesting. I would probably have actually designed that library so it was bound to a URL in a base URL in the first place and actually taking parameters. And I'm still in two minds. I've been doing Go for 16 years and I'm still in two minds whether I like this. But anyway, the third thing that I'm actually giving here is a function that you can call that will just take a slice of bytes. So effectively, I'm giving it a function that does exactly the same thing that a writer would do, where it could write to it, or a reader would do where it could read from it. This means I can use fetch web page wherever I want. And then if we come back over to the other side, when you read the logic of the main function, parallelize a bunch of stuff that involves a TLS collection to fetch a web page. And for each record in the web page, we've got a much easier way of composing our code than if I was to do a whole pile of the error handling in line and break it up into little functions that did each chunk in a row. So, and then over here, we've got the helpers that make this work. The parallelize worker, that's now out of date because Wait Group has changed its API this summer. At the time I was giving this talk, it hadn't yet. And then when Go for Con in London came along, it had. So that's kind of amusing. The old way of doing this, every time that you launched off a Go routine, you would add one or an arbitrary number, to be fair. This was part of the problem with the API, to a wait group. And eventually, when the wait group's value has come all the way back down to 0 due to done calls, then that wait at the end of the function would no longer wait and you'd fall out of the function. But of course, you can do more than add one. You can add 2, you can add 5. It was a horrible interface. So now it's been rewritten so that actually what you instead do is you just call one particular function that under the hood adds 1. And then it works exactly the same way. So anyway, I should have updated this for that, but I forgot that I'd got this in here. Over here, for each record, this is where we're doing our JavaScript, JSON unmarshalling. And you'll notice here that what we're actually doing is we're filling a byte buffer. And we've got this this funky little type signature here, slice of T as a structure. And it's our first example of generic code entering the mix, really, this and parallelize. Because obviously we don't want to tie down for each record to any particular kind of type. If we go back to where we're actually using it, you'll notice over here I don't have to specify the type. And that's because the function it takes as a parameter, that for each record takes as a parameter, is already typed on person. And if you come and look over here, the function in the for each record type signature, that T is the type on which TNE is working. So as a result, in here, I can create slices of whatever particular type for each record is going to be dealing with. And then that slice can be filled up with all of the different records that come out of the JSON. I think this is really nice. I find it, first time I wrote it, I thought it looked a bit weird. I must admit, I spent an awful lot of the last couple of years getting comfortable with how generics look on the page, because sometimes they look a bit funky. But in general, if you've got a bit of code like this and you can use a generic type, do use a generic type, because you're going to be reusing that code for lots of other things. It cuts down how much work you've got to do. Obviously, also, if there's an error, I log the error out. Oh yeah, I've put structure tags in. In this particular case, they're not particularly necessary because when JSON unmarshals, it doesn't care whether ID is capital I small d, small I small d, small I capital D, or capital I capital D. But I so rarely have an example in which I can show off structure tags. I thought I'd show them off here. And let's see, is there anything else back here that needs explaining? Probably not. Okay. So this would be if we were using client-side certificates. And there's some other stuff I've done over to the side that I'll get onto in a second. Client-side certificates just don't get used. But if you do want to use them, you have to actually create your own HTTP server and your own TLS server to do it. In this particular, and what you'll see here is there's a TLS configuration, just like there was previously. There's an address that you're actually serving on. And also you have to provide a handler that actually provides a MUX for splitting out the incoming connections. So that's what we've got here. Add routes is just a simple little bit of boilerplate so that I can stick a whole pile of different handlers onto a serve MUX. Because part of the problem is handler itself doesn't give you handle func as a function. You have to cast it as a HTTP serve MUX, or at least a pointer to one. And the code over on the right-hand side would be a nightmare with all of that inlined everywhere I wanted to actually set up another handler. So, boom. Apparently, I've started writing a web framework because we've got routes. Boom. Routes are handled quite simply by having a map of strings to a set of handler functions. So, get/hello has a function that goes with it. The add route just goes through, and for every single thing that's listed in that map, it just sets up a handler for it. Now, that does mean that obviously you could have map key collisions and you might get handlers that overwrite others. Maps are not actually iterated in any specified order, so that could lead to some very weird errors. So I just recommend not doing that thing. From the point of view of actually doing a production version, you could actually put a little bit of code in that as it went through, check to see if a map had already been defined for a particular route. And if it had, then obviously we just flag up an error for it. But anyway, the two handler functions over here, the top level one will just serve back a JSON file based on whatever you actually give it. But the get/hello, that gives us an override that guarantees that if a hello message comes in, request comes in, we give it back a hello world answer. So we've effectively got a system now where we've got a default behavior across all routes, but we can override that for specific routes. And it doesn't have to be gets, it can be puts, it can be posts, you can support delete verbs, whatever. So you can do some quite clever things. You'll also notice that I've got two different versions of creating the TLS server at the top. And that's because one of them is going to request the client cert, but it doesn't have to be there. And if you're testing with a self-created certificate, that's the one you want to use. Require and verify client cert actually does require it's a genuine cert issued by a certificate authority that can be checked against. So that's why there's two versions of that. The bottom one, the second of the two, is the one you would use in production code. The first is the one that you would use in test code. At some point, I'll come up with a cleaner way of representing that, because that's not very nice. It should probably be triggered by a command line option, or by testing to see whether or not it's actually running inside tests or something. Don't know. Different ways of handling it. Here we've got the client side of that. We've got a few little additions here, because now as a client, we ourselves need to provide a certificate. So we've got some code for loading a cert. You'll notice it's an X509 key pair. I don't really give much of a stuff about the detail of any of this. My business partner, obviously being a cryptographer, would go off for 20 minutes about how important this particular aspect of that was. But we've also got on the right, if you notice where we're creating the TLS client, we've got a system cert pool. Now that's all of the certificate authorities that the operating system you're running on knows about. So we are effectively loading in the default set of CAs for the box you're on. And then we can use that in our TLS configuration to say, well, here are our root CAs, and then we can add our own certificate. We can add to that set of root CAs a private certificate authority if we're using one internally, or if we're doing this on a box that should only be able to communicate inside the private system, we can actually just use a certificate authority that we privately run. So this allows us to actually effectively partition the outside world and the inside world just using cryptographic certificates. Because traffic to the outside world, well, we're never going to correctly negotiate because of making sure that certs exist at both ends. Whereas traffic internally it doesn't really have to worry too much about other transport security beyond TLS if we do this right. Of course, we can do this very wrong, and that's a completely separate talk. So for convenience, I'm using the same certain key as I was earlier on. Never do this in a real world system, ever. It's a horrible idea. But for testing purposes, for testing purposes for code for a talk, it's fine. Right, so that's HTTP, which everybody uses. Bye-bye. I spend most of my time poking around with TCP, IP, and UDP. So TCP is the bedrock upon which HTTP runs. So HTTP is effectively, call it a transport application layer that sits on top of TCP. And TCP is transmission control protocol. This makes sure that when two boxes talk to each other over the network, that each of them is talking in whole messages. Below that, you have UDP, which is user datagram protocol. When you're communicating with UDP, what you're sending is individual packets. And your message gets streamed across a whole pile of packets. And if some of those packets don't turn up, those portions of your message don't turn up. But with TCP, it's got various bits of encoding around it that make sure that the receiver knows how many packets it's looking for, and that each packet comes with an ID that tells it which point in the message it is. So if packets turn up out of order, it will all get reordered and everything. And most of that takes place in your network card. It doesn't actually take place in system software. Mostly, because most network cards you can put in promiscuous mode and you can read this stuff directly off the wire. There are various projects that use that to provide you user space networking. So, for example, inside a container, you might actually want each container to carry its own IP stack, in which case each container has the choice of talking through the operating system, which is quite slow, or talking directly to a network card that's bound to just that container or a set of containers and literally lifting the packet straight out, ordered as this way. So you can do some really funky stuff. That's all outside the scope of Go, though. Okay, so with TCP IP, it's connection oriented. So my code in main, you'll notice I want to handle a bunch of connections. And for each connection, I want to use a message loop. That message loop is going to give me a log message just to tell me where the request is coming from. And yet again, I'm serving up JSON files. So now I can have two TCP programs talking to each other where they're actually using JSON to transmit their transmit state. So it's not a very interesting particular example, but it loads a file. As long as that file actually has some content in it, it will strip out unnecessary end of lines to save some space on the wire or whatever. And then it will send a message back. So it's not doing anything particularly earth-shattering, but it's got all the components you need for a TCP server. It handles connections. It runs message loops for each of the connections. And for each of those connections, it can send back a response message, right? Handling connections is a horrible bit of code. I really should have put main over the other side and put handle connections on this side, but nothing quite fitted for doing this as 12 point that no less than 12 point that somebody could read from a distance. And then, so. But the first thing that we want to do when we're looking for connections is we need to listen on a network address. And for that, we've got a port and we've got an address. or rather, we've got a protocol, we've got an address. So if you look back at main, at handle connections there, our protocol is TCP. Now, that will handle TCP4 or TCP6, or more to the point, TCP running on IPv4 or IPv6. TCP4 and 6 are both usable as shortcuts for that, or you can, when we're listening on a specific address. In this case, I've given it localhost 1024, but that can be a domain name and a port number. It can just be a domain name. It can be an IP address. If you were doing the same code will allow you to use other networking stacks than IP Internet Protocol. So for those, they would have their own addressing mechanisms, but you would still end up with the same basic code pattern. And when you actually do that, you accept in a request once you're listening, and you'll notice this is an endless for loop. It doesn't have to be endless. You can put a condition there for shutting it down politely, but it doesn't make a lot of difference normally. For each connection that comes in, you have to accept it, which will give you a net connection that you can actually use. Or it will give you an error explaining what went wrong. And then for each one of those connections that comes in, you want to fork it off in its own Go routine. So the Go routine does all the processing, all of the work. And you'll notice here that I've chosen to pass in a function that takes the network connection. And once the Go routine is spawned, that function is called with that network connection. So when you're actually then writing the code up here for message loop, that's guaranteed to be in its own Go routine. You don't have to worry about concurrency. All of this stuff is thread safe and out the way. Message loop itself isn't really very complicated. There are certain things I'm checking for. I'm checking to see if there's an end of file. If there's an end of file, the connection's been dropped and I can log that. I'm checking to see if there's been an error, in which case I want to log that. If there hasn't been an error, then what I know is I've got a message, which will be a string, and or probably actually a slice of bytes, actually. But that message can be broken up into a set of tokens, and I can then process those tokens in this case. Everything that I would do with handling an incoming message is actually going to go in that function that's handled by the nil case. And that can be insanely complicated. I mean, you can have a full-blown parser there if you want for another language. I mean, I could stick a Python interpreter in there, say, or a Ruby interpreter, and I could feed that directly off the network, and then boom, I suddenly got a network compute client. Or it could be a binary protocol, or I could be talking ASN1, and I could be talking to some really low-level device over it. But all of it, the detail of it doesn't matter. It all lives in that one single function that we've passed in as a parameter. This is the client side. So in the client side, I basically want to dial to connect to a server. And I'm going to have basically, I'm going to treat this like a Unix command line tool. I'm going to give it a number of command line parameters, and each one of those is going to be a file name, and I'm going to say, please go and get these files. And so for each one of those files, in this case, read off the command line, I'm just then going to do a fetch file and print out the records that are in the file. So now I can have this sat as basically, effectively, it's a database client to a server that's serving me JSON code. To dial up the server, in here, you'll notice I've got a context. I'm not doing anything exciting with it. I've just got a 30-second timeout. So if the connection doesn't work after 30 seconds, bang. I'm using dial context. Now, a change that we've got coming in the next release of Go will actually give us some top-level functions in the net package for doing this, so that you can so you don't have to go through the palaver of specifically doing a dial with context. Yet again, for my server, I'm giving it a function that takes a network connection. When I've dialed it, I'm saying, right, connected to the server. This is what I want to do when I connect to the server. And then all the boilerplate doesn't really matter to me as the user of this function, but all this boilerplate is stuff you do really want to happen. So send message. Send message is just using a little bit of magic so that I can forcibly turn anything that can be turned into a string before I send it back. I always like to stick a bit of code in somewhere where I use a type switch, because otherwise people forget they exist. They're very handy. Unfortunately, there isn't really an underlying concrete type that can replace this particular switch, which is kind of annoying. You know, otherwise it could be written with the generic, but it can't. Receive message, the main funky thing I'm doing there is I'm dropping the \n, that will be at the end of the incoming buffer. And delete all is for stripping a whole pile of stuff of a certain pattern. So yeah, I'm not really interested in that at all. Mostly notable for the fact you're using, you'll notice I'm using generic type that's comparable. So anything that's comparable can be used as type T. That's necessary because you'll notice that in here, I'm comparing a V to a P. They both have to be of a comparable type for that to work. And they both have to be of the same type. So, boom. Oh, yeah. Adding TLS in looks very similar to doing TLS over HTTP, which isn't surprising because, you know, under the hood, it's doing the same thing. There's not really anything I want to say about it. I'll upload a copy of send Ainsley a copy of the slide deck afterwards. So I'm not really going to cover that. It's not really very interesting. Slightly more interesting with the client example, maybe. No, not really. So that's all. It follows the same patterns. We can do client-side cert checking, but we've already seen that with HTTP, and it's really just the same basic premise. So we'll skip past that. Boom, boom, boom. Right. UDP gets a really bad rap because UDP doesn't have any transmission protocol. I'm just firing raw packets into the void, it often feels like. And that's not really true. So if you think about online gaming, I think the first online game to support multiplayer was Quake. But the way in which it actually did that was with a particular variation of UDP called RUDP, which is where you just basically in each of the UDP packets, you just say, this is this packet in sequence. And then the client can go, I've got a whole pile of packets, but I didn't get that one. And they can ask for it again. In other words, you're doing some of the work TCP in your own code, but it can end up a lot lighter weight because actually on a well-behaved network and outside of major failures, most of the internet is relatively well behaved these days. User datagrams do generally get through. Instant messaging relies on them for presence detection and stuff like that. And you can afford to drop a few here and there, but you know, it mostly gets used for status protocols, for status messaging stuff, heartbeats, things like that. But anyway, UDP is a little bit weird to think about because it's peer-to-peer rather than client-server. So when you're writing your code, actually thinking of what to call things can be a bit of a pain in the butt. But, oh God, I hate talking about this particular code pattern. So the first thing you need to do is you need to actually resolve a UDP address. And there's an awful lot of very unnecessary repetition going on there between the UDP address and the whole give it a UDP protocol thing. I don't really like that. I really wish that this library would get a bit of an update for that. And then you want to listen on UDP, and yet again, you say UDP. But the main point about UDP is I need to create my own buffers to receive stuff into because I'm going to be receiving buffers of literally just 512 byte or 1024 or whatever. By default, UDP is 512 bytes per packet. And on the public internet, that is what you can normally rely upon. On private networks, it's not unusual for people to use 1500 bytes for a buffer for a packet. And then you have super packets, which can be 1,000,000 bytes. And they do have very practical uses, mostly in infrastructure.
Sorry, Ellen, I don't want to interrupt you on your way, but we've got about 5 minutes left, just so you know.
Okay. We're not going to get to crypto, but that's fine. I'll send up the slide deck. Okay.
No, maybe we could do part 2. That would be amazing. I'm really enjoying it.
It's a nightmare talk to give, to be honest. It's not one of my easier ones to actually talk through. The main thing with UDP is everybody is listening. clients listening, servers listening, because actually there is no client, there is no server, your peers. So in this particular case, I'm listening for some UDP. Someone's going to talk to me. I need to read from that connection that I'm going to get, and it's not really a connection. So it's like, you know, I've given it a C for connection, but it's not really a connection. I'm literally just any packet that comes in, I'm going to do something with. And in this case, for every single packet that comes in, I'm going to write a packet back out. So we can actually, though, think of that at somewhat higher levels of abstraction. We can send messages over it, but what's actually going to happen is that Go itself is going to send a succession of packets with different portions of the messaging, and we just have to hope they're going to arrive where they're going to arrive. I'm going to skip past all of that. God help us. Where it starts to get interesting, at this level, I'm now in a position where I'm completely in charge of doing my own cryptography if I want to. There is no such thing as TLS for UDP. TLS requires a connection because it's a connection-oriented protocol. This code here does a whole pile of insane stuff to do AES encryption. I'm using AES in CBC block cipher mode. You're not supposed to do that with stream data. You're supposed to use something like Galois, and Go supports all the different block cipher modes. And I really don't actually want to get into, no, I don't want to get into any of that. I can't really give you meaningful coverage in the time. We've got a few other things going on. Command line flags. I've got a bit of code in here for covering that, which I cannot now find. RSA. All right, I am going to cover the difference between AES and RSA because this matters. So RSA is public-private key crypto. This is where you have a private key. From that can be derived a public key that can be given to anybody. Nobody can figure out what the private key is from the public key. And this is because the public key is derived from the private key using modular arithmetic, you know, like on clocks. So there are many candidate private keys that can work with a particular public key. But there's no way to figure out the small set of public keys, or rather the large set of public keys that could apply to the private key. So you just can't derive the private key from the public, but you can the public from the private. It is a really weak form of cryptography. You should never use it for encrypting files. And in fact, there's no block mode. So this means that if you've got a 4 kilobit key, the biggest message you can encrypt with that key is 4 kilobits. There's no defined protocol for taking an 8 kilobit file and encrypting it with twice with a 4 kilobit key. But if you want to exchange small pieces of data, like a symmetric key, which is generally going to be 16 or 32 bytes long, then public key cryptography is brilliant because it's just going to completely swamp the appearance of that key in it. The key itself is random. You have nothing to pin to it to figure out what is being transported in that thing. And RSA is a great way of doing that. And TLS uses a particular kind of key exchange called Diffie-Hellman, where effectively I do a certain thing and you do a certain thing, and we do the certain thing the right way. And from that, we end up with me now having a symmetric key. The RSA stuff is only ever really used to set up the AES ciphers. Once you've got an AES cipher, it's a 16 or 32 byte key, but it has defined modes for using that to encrypt arbitrarily long streams of data. So as a result, you can just use that. And as long as your keys are random and you don't share them across lots of different sources, then you have a very, very secure form of communication. So that covers that. You can put the two of them together to do something called hybrid cryptography. I have some slide decks online on that, although they're mostly in Ruby. I'm not going to cover WebSocket, but there's some code in here for playing with WebSockets. And the great thing with WebSockets is they live inside your browser. They're a TCP/IP connection that actually lives inside your browser code in JavaScript. And you can turn on TLS in them trivially just by, instead of using WS:// using WSS://. And so straight away you get the security. You can also use WebSockets to talk directly between clients that you write and servers that you write without any web involved whatsoever.
I'm so sorry to interrupt, Eleanor.
There you are.
That was really, I have to say, I really enjoyed that. And I feel so bad for butting in because it was
no.
It was so interesting. And it's so interesting seeing like your take on functional programming. Yeah, it's really insightful.
Yeah, I don't like talking about the functional stuff outside of actual talks on the talks I do on functional programming, because so many people have a very, very determined view about what coding in Go looks like.
Yeah.
And
yeah,
I've been doing the same basic style of Go coding since I started coding on November the 10th, 2009. But that's because I came out of Ruby, and in the Ruby world we write higher order functions all the time. It's what our code pattern is, and Go has closures. There is literally no reason not to use them. They make so many things much easier. But people don't. They're scared.
I'm just going to go. Well, no, honestly, thank you so much, and thank you for everyone attending. I've just got a couple of more announcements. And Eleanor, thank you. Please feel free to come back and do a part 2 because, if
somebody wants me to, I'm more than happy.
Oh no, absolutely. So just a couple more announcements before we wrap up. I know there's an all hands at 3. So I think we nearly have a date with the London Gophers in April, which is amazing. Eleanor, perhaps you can come along to Fleet Place House in London. I think it's in April, but await. Watch this space with announcements. And the second thing is we have some news that I'm sure you heard at the beginning is that I'll be training up a little extra small gopher in about a week's time. So I'm gonna pass the baton over to Mr. Jake Howden. So Jake, you're gonna be go man for a few months. I really appreciate that. You've been working in .NET for quite a long time, is that right?
Yeah. So I did game dev at uni and kind of fell into .NET, but yeah, been doing it for my whole career. So, and Jet's kind of the first time I've had an opportunity to get interested in Go. So yeah, very excited to head up the guild for a little bit. Yeah.
Nice, man. No, that's really cool. And you're in the Bristol offices, right? So you can spread some Go love down in Bristol.
Yes, definitely. Yeah. It's a lot of London-based people, I think, isn't it? Yeah.
Yeah. No, absolutely. Well, thank you very much, and appreciate. And Jake, we'll see you all next month. And yeah, have a lovely afternoon. Thank you, Eleanor, again.
Cool. Thanks very much.
Thank
Have
you.
a good day.
Bye-bye.
Bye.